Already we have discussed in the collaborative filtering. After finding this matrix, whenever there is a question mark, we can predict this particular rating even though the user did not access the video MATLAB. The MATLAB video is not at all accessed by the user, but we can predict what would have been the rating that will be given by him if he would have accessed that particular video. That we have already discussed. Now in this class we are discussing, there is a new user, Eve. This particular user has not accessed any video, even not at all a single video. Now we don't know what is the Eve's interest. Whether the Eve is interested in programming content, we do not know. Whether the Eve is interested in technical content, we do not know, because that particular Eve has not accessed even a single video. All ratings are indicating with the question mark. Now our problem is to find out what is the content, what are the products you are going to recommend to this particular Eve. We already discussed in the previous classes. For the collaborative filtering, we are simultaneously finding the x and theta feature and parameters. So simultaneously we are finding. That's why we are using here the two regularization terms with respect to x and with respect to theta. These things we already discussed in the previous classes. Because I do not have any ratings for this particular user, and for every video we are taking two features. That two features may be, I may take one feature as programming content in that particular video. I may take another feature as what is the technical aspects in that particular video. I am only restricting for two features. That means every video, irrespective whether it is C programming video or MATLAB video or PLC or EDPS or BE lab, every video is having two features only. Remember, we are not taking X naught here. The X naught and theta naught we are not taking in this. Already about this we have discussed in the previous classes. Now because we are having two features, in the theta also we have two elements. We are taking initially the two elements as 0, means theta 1 0 and theta 2 0. Because the matrix theta is 0, if we multiply theta into x, whatever may be the values of the x, because the theta elements in the theta are 0, the final result is 0. This is indicating all the elements, means all the ratings will be 0 for the Eve, even if we predict. There is a problem. How an user called Eve even did not access a single video, how can he give a rating 0 for the particular video? Now, because we do not have any information about this person, we have to move this problem forward by taking the mean normalization. This mean normalization already we are discussing from the previous classes also. Similarly, we do the mean normalization here with a little difference. We will observe that. And you have to see this factor also, because the regularization term, because the theta 1 and theta 2 are 0, this term is also becoming 0 for the initial values we are taking. Now what is this mean normalization? First we have to find the mean. We are having four elements here. I am calling every rating as an element of the matrix because all ratings are included in the matrix itself. Now because we are having four elements in the first matrix, I am not including the question mark because I do not know what is the value. I have to find the value of this question mark, so I am not including. So because we are having four elements and we are taking the average of this, 5 plus 5 10, 10 by 4, that is giving 2.5. In the second row we are similarly taking 5 plus 0 by 2, that is 2.5. In the third row we are taking 4 plus 0 by 2, that is 2. In the fourth row we are taking 0 plus 0 plus 5 plus 4. 4 elements are there, so 9 by 4 it is giving 2.25. In the fourth row we have 4 elements and only one 5-star rating is there, so 5 by 4 it is giving 1.25. so our mean is ready. Remember, we are not including the question marks. We are only taking the ratings that are given by the users after accessing the video. Now the matrix, we are calling this matrix as mu. This is our mean. This mean normalization concept, we have different elements in the matrix Y. We want to subtract each element of the first row with the mean of the, we are taking the mean, first row mean of the mu. So we are subtracting 5 minus 2.5, result is 2.5. Similarly, 5 minus 2.5, result is 2.5. 0 minus 2.5, minus 2.5, minus 2.5. We are not subtracting the question mark with 2.5 because we do not know what is that rating. Similarly, in the second row also, we are subtracting this 5 and 0 with the 2.5. Now our new matrix, we are calling this matrix as mean normalized matrix, means the elements which I am circling here are having zero mean. The zero mean matrix we can say, because we have normalized this matrix. Now we can use this matrix to find the ratings, or we can find what products or what videos we can recommend to that particular you who has not accessed even a single video and whose interests are not known to us. By using this mean normalization, that problem can be solved. First, as similar to the previous problem, we have to find the theta and x. Theta is the parameter matrix, we already know. Here the J is indicating that particular user. Here, the J is indicating the user. Theta superscript 1 means this is the parameter matrix of the first user. And similarly, theta superscript n represents the parameter matrix of the nth user. Here, the parameter means the interests of that particular user are included in this matrix. And similarly, we are taking x superscript I. These are features of that particular video or product. It means C programming video, the features are included in x superscript 1. Similarly, the MATLAB features are included in x superscript 2. We are taking only two features here. One is programming and the second one is technical aspects. So we are multiplying theta j transpose with x superscript I, and we are adding mean. Why we have to add mean? Because we have subtracted the mean. When we want to get the original ratings, we have to add the mean. As we already discussed, because the elements of the EU, the interests are theta 5, theta superscript 5, the elements in this parameter matrix are 0. Even if we multiply with any features with theta 5 matrix, resultant is 0. Because this matrix resultant is 0, we are adding only mean. The resultant is mean. So whatever the mean we got, 2.5, 2.5, 2, 2.25, 1.25, simply you can substitute this mean here. So what is the rating? What is the rating that Eve is giving for the C programming video? 2.5. How we are telling? Even that particular Eve has not accessed the video. We are telling based on the ratings that are given by the all different persons. This is how, when we open a site like Amazon, first time, by logging the credentials by using Gmail or anything, after logging on, where some recommendations are shown to us, we will surprise. Even we have not bought even a single product, how they are showing this content based on the interests of the many users. And similarly, if you open the YouTube, some videos that will be shown, even if it is your first time access to the YouTube also, some videos that are major popular videos are shown to you, because at the time YouTube or Amazon or any social, any company that is requiring, that is working with the customers in the social domain, they do not know what are your interests. They simply suggest the videos or products based on the interest of the large amount of the users. So that's why we are taking the mean, and after normalization of the mean, we are giving the ratings 2.5, 2.52 and 2.25, 1.25. Based on this, we can suggest that okay, this particular you may like the C programming video, because out of all these 5 videos, only C programming video and MATLAB video are having the highest ratings. So we will recommend the C programming and MATLAB videos to you, thinking that you may like these videos, because majority of the interest, majority of users liked these particular videos, more ratings are there. Out of all 5 videos, we may recommend these 2 videos. So this is how, even though we do not know the ratings of a particular user, we may recommend those particular products or videos to the user.